Welcome back to Vectoring AI, where we explore the history and future of artificial intelligence. In our last episode, we looked at the 1980s, a decade of booming expert systems, international competition, and, ultimately, a second AI winter. By the early 1990s, optimism had cooled once again. Funding was limited, and many grand promises of human-like intelligence had failed to materialize. But beneath the surface, new methods were quietly reshaping the field. The 1990s became a turning point, where artificial intelligence shifted from rule-based reasoning to data-driven learning, laying the mathematical and empirical foundation for what was to come.
One of the most important changes of the decade was the rise of statistical and probabilistic approaches. Instead of relying on handcrafted rules, researchers began creating algorithms that could learn patterns directly from data. Decision trees, such as the C4.5 algorithm developed by Ross Quinlan in 1993, could automatically induce classification rules by analyzing examples. Support vector machines, introduced in 1995 by Corinna Cortez and Vladimir Vapnik, quickly became a leading method for pattern recognition. And in 1997, the AdaBoost algorithm showed that combining many simple models could produce a highly accurate predictor. These methods were rigorous, grounded in statistics and optimization, and they often outperformed the symbolic approaches of the past. The phrase machine learning gained popularity, marking a clear distinction from what was sometimes called good old-fashioned AI.
These advances quickly found their way into real-world applications. Speech recognition became commercially viable thanks to statistical models known as hidden Markov models. In 1997, Dragon Naturally Speaking was released, one of the first consumer dictation tools. Email spam filtering began using probabilistic models like naive Bayes, quietly improving the online experience. Computer vision also shifted towards statistical techniques, with early face detection systems like those developed by Turk and Pentland in 1991. For many users, AI was no longer a futuristic promise. It was starting to appear in everyday software, even if in narrow, specialized forms.
The decade also brought dramatic moments that captured the world's attention. The most famous was in 1997, when IBM's Deep Blue supercomputer defeated world chess champion Garry Kasparov. Deep Blue was not a learning system, but a triumph of brute force search combined with expert heuristics and custom hardware, evaluating hundreds of millions of positions per second. The match was broadcast worldwide and symbolized a turning point. A machine had conquered one of the ultimate intellectual games. Kasparov himself admitted he felt a new kind of intelligence sitting across the table. The victory cemented AI's place in the public imagination, even as researchers remained cautious about its broader progress.
Robotics also advanced significantly during the 1990s. In 1995, Carnegie Mellon's NavLab project demonstrated ALVINN, a semi-autonomous van that drove across the United States, guided by a neural network that mapped camera input to steering commands. It was an early step toward the self-driving cars we know today. In Europe, the RHINO project in 1997 deployed a museum tour guide robot that could navigate hallways using probabilistic localization, a method for handling uncertainty in perception. Consumer robotics took a playful form in 1999 when Sony introduced the AIBO robotic dog, bringing AI and robotics into homes. And perhaps the most iconic robotic achievement of the decade happened in 1997, when NASA's Sojourner rover successfully explored the surface of Mars, using AI techniques for planning and autonomy to operate millions of miles from Earth.
In academic circles, the 1990s were also a time of reconciliation between symbolic and statistical traditions. Judea Pearl's work on Bayesian networks provided a principled framework for reasoning under uncertainty, influencing fields from medicine to computer vision. Planning algorithms increasingly adopted probabilistic models, such as Markov decision processes, to account for real-world variability. At the same time, roboticist Rodney Brooks advanced the idea of intelligence without representation, simple, behavior-based agents that could achieve complex tasks through direct interaction with their environment. His ideas influenced insect-like robots, and later, practical products like the Roomba robotic vacuum.
By the end of the 1990s, AI had changed its identity. It was less about grand visions of human-level intelligence and more about specialized, measurable progress. In fact, many areas that had once been part of AI, computer vision, speech recognition, robotics, machine learning, had become their own disciplines with separate conferences and research communities. To some, AI as a unified field seemed to be disappearing. Yet paradoxically, AI was becoming more integrated into everyday technologies than ever before. With faster computers, growing data sets, and the first signs of internet-scale information, the groundwork was being laid for the breakthroughs of the 21st century.
The 1990s were therefore a decade of quiet transformation. They lacked the sweeping hype of earlier eras, but they delivered practical methods, real applications, and headline moments that reshaped public perception. The field had become more modest, but also more rigorous. And in that humility, AI found the stability it needed to prepare for its next great leap.
In our next episode, we will move into the 2000s, when AI entered the internet age, data became the new fuel, and machine learning began its rise toward the deep learning revolution.
Thanks for tuning in to Vectoring AI. If you enjoyed this episode, don't forget to like, subscribe, and share the channel. Stay with us as we continue exploring the unfolding journey of artificial intelligence.